Panchevar, and in this YouTube series, we'll be solving DSA sheet by Siddharth Singh. So today's one of the first sums, day 1 or day 0, whatever you call, and the sum's name is squares of a sorted array. Uh, Let me just go to the link of this question. So this is the question. I guess when I do full screen, you won't be able to see my face. Yeah. So this is our question, squares of a sorted array. Basically, we have been given an array in an increasing order. Increasing is 1, 2, 3, 4, 5, and we have to return a array like the we have to return an array with squares of each number. So this question sounds really easy, and but it is not. Like it's highly intuitive. The solution, the brute force solution, is like super damn intuitive, but you have to handle a test case which we'll discuss. So here is the question. So squares of a sorted array, as you all can see, we are into the Miro board or Miro board. So this is, suppose this is our array comprising of 1, 2, 3, 4, 5. Some of you all may be like, why is this even question in the sheet? This could be damn easy for some people. So let me just do, like, we'll just iterate the array, and we'll just, what are the squares? 2 square is 4, 3 square is 9, 4 square is 16, and 5 square is 25. So this should be the answer. But here you have missed one test case. What if the numbers are negative? So let's just see that case. So here I have a test case where my numbers are negative. So what, okay, if you do according to your old method, which is 4 minus 4 square is gonna be 16, minus 1 square is gonna be 1, 0 square 0, 3 square 9, 10 square 100. Voila, you don't have an answer right now. So what do we do? Okay, still, I think at that point when I don't know the approach, I would just sort the array. So the sorting of array is gonna be take me log n. So after sorting the array, I'll get my answer. But why did they even care about giving the array in increasing order? You should think about that. Like, it's not a super straightforward sum, even if it seems to be straightforward. So we will discuss another approach to this problem, because this is n log n and they are expecting in O of n, big O of n solution. Why it is n log n? Because sorting of this array is going to take n log n complexity. Now let's discuss the approach that I've been awaiting since the video. So this is your array, right? And let's see. Now just tell me which are the two candidates that you feel are which are the two potential candidates whose square can be maximum. I think the most negative and the most positive number, so basically this number square or this number square, these both candidates are potential candidates to be maximum, to fit here. So our result array is also going to be in increasing order. So this is gonna be the place where highest number, like highest square, gonna come or sit. So I think this could be the answer or this could be the answer. Now in this case, 10 square 100 will come here obviously. But what if the case is, let me just discuss, what if you have minus 7 tab 4? What if you have these two numbers, like on left side, extreme left side, you have minus 7, on extreme right side you have positive 4. Minus 7 square, someone, yeah, 49, perfect. And 4 square is 16, right? So okay, so you got my point, right? So these two candidates are going to be my potential candidates who can come and fit here. So what's my approach gonna be? I'll have, this is also called as two-pointer approach. So I'll have basically 3 pointers. First of all, I'll make a new array called as result. So this is my new array called as result, in which I'll be storing my answer. Second step would be I'll assign 3 pointers. Now why do I need 3 pointers? One would be the most negative element, second would be the most positive element, third would be one which will be helping me to iterate in the result array, where I'll be placing my answers basically. So one I have I pointer here which will be pointing towards the most negative element. We have j pointer here which will be pointing towards the most positive element. We have the index pointer here which will be pointing to the last position in the result array. Even before dry running with it without code, okay, let's dry run it without code. I thought of like coding and dry running, but this also works. So basically first what we'll do is I could try to like code simultaneously and dry run. I'll keep two values. Okay, so val1 is gonna be array of I, it's gonna be array of I square. Val2 is going to be array of j square. So these are my two potential candidates which I was speaking about. Like either val1 is gonna fit in index or val2 is gonna fit on the index position. So what I will check here, if val1 is greater than val2, what's the step? Or we won't like, we'll just do indentation. Val1, what if val1 is greater than val2? Inside the result array, I'll have index position pair, I'll have the element val1. After that, what I'll do is index is gonna increment. Index is always going to decrement. Sorry, index is always going to decrement in any case. So I won't do it here. But what's compulsory gonna increase if val1 is greater? If val1 comes to be greater, I'll do I plus plus. You'll understand it more when I'll be dry running it nicely. So don't worry if you're not understanding it right now. So else what is the val2 is greater or like equal to val1, right? So what we'll do here is we'll store at this position. What we'll store val2 and we'll do j minus minus. So the 100 came here, so this will be j minus minus. This will go here. And in any case, what I have to do, I have to decrement index. Okay, so this is brutally the code. Like it is super, in dry run itself, we wrote our code, which is great. But I think some of you have not understood it, and I totally understand why didn't you understand it. So let me just take a pen. Where's the pen option? So I'm not used to Miro, but I guess you have it here somewhere. Let me full screen. Yeah. Yeah. Okay. When I full screen, I got to see it. It's weird. Okay. So let's start our try run. So first we'll calculate val1, which is array of I into array of I. So this is Ri. So minus 4 into minus 4 is perfect, 16. Next we'll calculate val2, which is the most positive element square, which comes to be 100. After that we'll compare if val1, we'll compare 16 is greater than 100. No, it's not. We'll come into the else part. In else part, what do? We store the greater element into the result index position. So what here comes 100. And we also do j minus minus, meaning we'll move the pointer here. It's not moving together, but it's okay. Okay, So this happened, and after that, after the if else thing, we'll do index minus minus irrespective of val1 is greater or val2 is greater, because we have to iterate through this array, right? Now comes again I lost my pen. Okay, 2 minutes. Yeah. So right now this is the position. I'll take the eraser and erase this. Now let's again calculate val1 and val2. Okay. Let's calculate val1 and val2. Right now my I is here, so again val1 is gonna be 16, val2 is gonna be 9. You always need a lot of patience while dry running, and in every dry run you get to learn something. Like, it's never you'll think it's easy, but still there's, I don't know if it's a catch or not, but for me, if I don't dry run, I won't understand, like, yeah, I am missing this. So you need patience. Go along the through the video, even if it's tiring. Just dry run yourself, pause the video and try to dry run. That is gonna always help you in some way or the other. So I have 16 and 9. What's this case? So my val1 is greater than val2. So what do? We'll store 16 here. Once we store 16 here, this is done. Now we are doing I plus plus. So we'll move our pointers here. What's the next step? We come out of the else and we do index minus minus. I hope you are understanding it right now. Okay. Now again, we have to calculate. Oh my god, what's happening? I think I need some kind of solution to this. Yeah, it's here. No. Yeah, I got it. So let's go to the eraser and erase the previous values and recalculate what's val1 and val2. Right now I is -1 and j is 3. So in val1 we have 1, in val2 we have 9. Here val2 is greater than val1, so we'll come inside the else condition. What does else suggest? You just put the value here, then you move the j to minus minus, which will lead to, okay, uh, you shift the value of j here, then you we are out of the else, and now you decrease the index, and then you recalculate the values of value 1 and value 2. Again I'll erase these values, old values, and recalculate. Now what's the value of val1? Val1 is again 1, val2 is 0. This time val1 is greater than val2, so we'll put here 1. Now it's time to move the I pointer. Why I pointer? Because we came inside this if. So right now it's here, I comes here. This is the point I want to realize, like, why dry runs are super necessary. So we are right now here, and we come out of the if else part, and we have to decrease the, oh my god, what's happening? Okay, so we have to select it. Yeah, come on, Zed. Yeah, now it looks straight. I want to pick this up. Yeah. Mm. Okay, this isn't moving. So I do Command C or Command X and paste it here. Yep. This worked somehow. I don't know how I made it work. Yeah. So now our index is here. Okay. Now at this point, I want you all to realize when I becomes equal to j, we don't stop there. We actually try to, like, we are still calculating, so the loop that's gonna stop our the iteration is gonna be while I is less than equal to j, and not while I is less than j. Like, this is something that you realize while you're doing binary search. At that time also we use while I is less than equal to j. Why? Because it's one box. When I is equal to j, you didn't calculate anything for this box yet, so you have to do it. So again, let's just do, we are about to end this process of dry running. Let's try to erase the old values again, and at this point we have here 0, we have here 0. We'll come inside the else, and we'll basically store here 0. Now what will happen is, um, we'll do index minus minus. So basically index is gonna shift here. Here we'll have index, and we'll just cut this we don't have right now. And this will happen at the last. Before that, what, just stay true to your dry run, okay? It's gonna help you a lot. Like, so we won't do, I just erased it. Staying true to my dry run. And now where I was here, right? So I'll do j minus minus, so j will come here. At this point, I has crossed j. So we have to stop our loop, and we are done, and we will return our array, and this is our answer. So yeah, hooray, you did the solution. Now let's try to code it on Leetcode and just make a submit to be double sure. So for what are the steps? First we first we make our result array. So int result, new int, so what's the length of this array? I guess nums dot length, like the same length. Then we'll be having 3 pointers. Int I equals 0, which will point towards the most negative element. Int j equals nums dot length minus 1, which will point towards the most positive element. And int index, which will be there inside, which will be iterating through our result array, which will be nums dot length minus 1. Now we start our while loop, and we already know the condition. Because of dry running, I is less than equal to j and not I is less than j. It's kind of a beginner mistake that a person can make, but if you're doing DSA since a while, you get hang of this concept. Now inside the while loop, first we'll calculate val1. What is val1? It's nums of I into nums of I. Inside val2, we'll have nums of j into nums of j. Here we'll compare. So basically, if val1 is greater than val2, what we'll do, we'll store the result at the index pointer of val1. After storing the result, we'll just do I plus plus. Else result of index equals val2 and j minus minus. And this is the step that we all have to do compulsorily, which is basically will decrease the index pointer. At the end, you have to just return your result array, and let's try to run the code. Let's try to submit it. Yep, so it got submitted, and hooray, we did this question. Few things that I want you all to meditate upon while doing this question is, first of all, like, someone who just started DSA is obviously gonna just square it and then sort it, but just give a thought, why did they even care about giving a array which is in increasing order or a non-decreasing order as they suggest? So why? Like, there will be a reason, right? Second, time complexity, just be careful, like the solution should be no often. And the third would be I is less than equal to j. At that point you have to stop, and just remember, whenever this question comes, two pointer approach is something that your mind uh, should know. Like, yeah, this question I'm gonna do it by two pointer approach. So thanks a lot for watching this video. So this video is from actually this is a sheet that I've been following. It is a sheet by Siddharth Singh. So let's try to color code as he suggested. I'll link the sheet in the description box below. I think this problem was from easy set, so I'll just color code it to easy. You can color code it to any color that you want. So I think it didn't get paste. Okay, I just copied twice, I guess. So copy and then just paste. The comment that I would like to write here is gonna be two pointer approach, not even approach, like two pointer. And I think that is enough for me to revise. So thank you. Keep solving DSA questions. I've been solving this sheet. I'm a beginner, to be honest. That's why I've been explaining small stuff to y'all, like that really made me think. So thanks a lot for watching this video. Continue solving further questions.